My name is Sarah Drasner. I work for Microsoft as a senior developer advocate, and I'm here to talk to you today about data in motion. So let's start from the beginning. I heard that that's a pretty good place to start. What happens when you look at an image or a website or any kind of still image? Your eye is constantly tracking around that image. So in that, just still image, you see this heat map on top of it. And that's because it's actually tracing where the eye is going. You can see it's actually not staying in one place. I'm going to actually grab this off of here. Your eyes scan the environment around them in an event called saccade. So this is an eye looking at one image, just one image. We're doing that so that we can create a spatial map of all of the things inside of that image. And we do this constantly, all of the time. And we're building up a mental map of that space. And why is that important? Well, we're predators, so we need to kind of find food in the brush. There are prey that are camouflaged, and we can see them better if they're in motion. We're also we have predators, so we need to see if something's moving so we can run away, which means that when you're looking at something on the web or any kind of image, evolutionarily speaking, you are scanning this environment to look for motion. The thing that's in motion is going to capture your attention the most. So motion guides us. If we're looking at a sea of similar kind of data, the ones that are actually moving are the ones that are gathering our attention the most. And for that reason, we have to be very careful about how we animate, because some things can draw our attention too much, and we can actually guide our users with that motion. So today, we're going to break down meaningful motion with data. So how are we going to do this? There's a few main principles that we'll use in applying motion. Filtering and reordering is one of them. Showing greater context is another. Showing change over time is probably the one you're pretty used to. And revealing for clarity is also a really important one. So let's start off with filtering and reordering. Filtering and reordering is something that we can actually do without motion, but motion allows us to keep the context of the first piece of data that we were seeing. So it allows us to kind of track those in-between states and retain the context of what has changed as well as why. So therefore, it's another view of that same data. This gives us more information about larger trends in our data sets. So how can we accomplish something like filtering and reordering technically? Here's one simple example I made that shows the use of D3 chain transitions. You're probably pretty used to these. If you've worked with D3 a lot, it'll be very comfortable to you. You're basically kind of imperatively saying, transition, and then you're saying what attributes you want changed, as well as some delays and some, durations. And D3 makes good use of SVG, so it tends to inherit some of its idiosyncrasies. Anytime we manipulate data and change something like a polygon or a polyline to another data set that has a different amount of path points, there's some really weird things that can happen when you add data points. So there's this library by Peter Bashai that allows you to interpolate these paths in a smoother manner by adding those path points to the data set before interpolating, so that the intermediary values look a little bit smoother and we can kind of track them a little bit easier. And that type of transition between values is really nice for something like polygons and polylines, and it works well. But what if you want to do really complex data? So I used to live in the Mission in San Francisco, and there were a lot of types of people that I would meet, and it was kind of interchangeable hipsters. So I made this using Green Sock Animation API and its Morph SVG utility. And what the Morph SVG utility allows us to do is interpolate between completely different amounts of path values and really, really complex shapes. So Green Sock is an animation library I'm going to bring up again and again, because it's really, really good for complex and sequential data structures, and also any kind of advanced movement, and we're going to dig into how we can use it for those. It's really good for razzle-dazzle, which is a technical term. And you can do whatever kind of morph with that data that you would like, So here's an example of the syntax. It's really, really simple. We're telling GreenSock or Tweenlight here to morph between the shape of a circle to a square. I work for a publication called CSS Tricks, and the guy who runs it, Chris Coyer, asked me to do like a logo, an Easter egg logo. So if you hover over the dash, you can click on it, and then all these nerdy things happen, like the S becomes a link, and then the T becomes a fork. Our K is a query selector all-star. So, you know, it's kind of as nerdy and fun as you can get, being kind of like a mystery logo. But one of the most amazing things about Morph SVG, aside from the simplicity of its implementation, is the way that you can actually manipulate the values of how that motion works. So you can use a utility called find shape index and actually find these different amounts of changes. So we're changing between, you know, like a polygon here to a star shape. And by changing the index of where it's interpolating from, you can see that that motion is totally different. That's a completely different way of showing those forms. So in some ways, the genius isn't even how simple it is to use, but these kind of small things that allow you to really, really fine-tune and control how that data is going to look. So using something like Morph SVG, I can animate things like different path points in an array, and I can also even animate filters with GreenSock. So I can make something like a candle flame out of SVG and math. And that's really, really fun and cool that you can animate unanimatable properties. I'm actually animating a filter here because, you know, request animation frame doesn't care if it's an animatable property or not. And I can make smoke. So in terms of filtering and reordering, you have actually a lot of tools available to you, but my kind of quick TLDR would be if you have simple transitions between simple attributes, D3 works really well to filter those kind of simple attributes. But if you need to do something more complex and kind of push the boundaries of how you're going to show that data or maybe manipulate that data into a completely different way of viewing it, which I suggest you try, definitely check out GreenSock for those. All right, we've already done a lot, and we've got 3 more to go. Let's look at showing some greater context. So we spoke earlier about how we're creating these spatial maps in order to understand where we are and what we're looking at. And you might have seen this example before. Our burners and their knobs that were associated with them used to have this kind of relationship. And it was really, really, it took a certain amount of cognitive load to figure out which burner and which knob was associated. But if you just change them slightly, all of a sudden that cognitive load is reduced. So just changing those relationships can really help people understand our data much quicker. This example is from Kathy Sierra's book, Badass Making Users Awesome. Definitely check out that book. It's just like a wealth of knowledge of these kinds of cognitive load and spatial awareness ideas. So we can use this idea of spatial awareness and especially relationships between things to show greater context and actually show what the nature of data is trying to reveal. Oh, I think the sound's not on.
We don't see colonial wars anymore.
Let's go back.
To many, peace is too strong of a word. Wars have occurred since World War II, and they can be grouped into these 4 categories. We don't see colonial wars anymore. We've already noted that interstate wars between rich countries have not occurred at all. And here we see wars involving smaller economies have tapered off. That leaves civil wars of 2 types, with and without foreign intervention. And this is what these battle deaths look like alongside of World War II. More people died fighting in World War II than in all the wars since. And again, we can't forget about world population, which has almost tripled since World War II. If we scale these numbers to show deaths in proportion to world population, showing the likelihood that a person on Earth dies in battle, the downward trend becomes even more pronounced. Now, this isn't to infer anything about why this trend is occurring. That's a discussion for another day. You can now interact with this chart to explore what conflicts are behind the totals. Now bear in mind, we're just looking at battle deaths here, not civilian deaths, but those too are in decline. Peace is a difficult thing to measure. It's a bit like counting the people who didn't die in wars that never happened. We give such importance to the word peace, but we don't tend to notice it when it occurs. or report on it. Sometimes it takes reminding ourselves of how terrible war once was to see the peace that has been growing around us. Of course, this trend may not continue, and it's not clear how looking at these charts can help us make the right decisions to ensure that it does. But the longer the long peace grows, the more significant it becomes. So if watching the news doesn't make us feel hopeful about where things are heading, watching the numbers might.
So I really love that example. I think it really does a great job of illustrating what a greater context you can show, especially if you're showing the same data set, but just in a different way and kind of moving in and out of that data set. It becomes really powerful. So you might be thinking to yourself, well, but that's a video and we're coding things on the web. But actually, you can make good use of the SVG's view box as a camera. So let's dig into how you can kind of pull that off technically. So if you're not familiar, you're probably familiar with ViewBox, but just in case, so I drew this in Illustrator, and if we were looking at the view box, basically like to understand how SVG is working with that coordinate system, it's almost like you have an infinite graph. It's just infinite in every direction. And you're plotting these coordinate points through this infinite graph. Our view box is our view into that information. It's basically our window to see into where we are in that space. So if I was going to plot out seeing this information, that's pretty normal, right? We've got top and left, 0, 0, width and height. So 384.5 and 250. So let's say I wanted a different view on this and I actually just wanted to get the houses instead. I could remap that, set the attributes of that to, 215, 160, 42.2, and 20. And then all of a sudden I'm looking at the houses instead. But it's kind of a bummer to go like plot things in Illustrator. Who does that with DataViz? Nobody. So actually there's a native method called getBbox that returns an object called svgrect that has inside of it x, y, width, and height. That's pretty cool because that's what we need. So what we can do is we can get information about a group or any kind of path or anything. And that's really what the browser is seeing are these small boxes for each one of these elements. So we can get information about this. I'm using string concatenation here, but if you use ES6, template literals are actually much more legible. So then I can set the attribute of those and just zoom in on the houses. And if I comment these out, you can see that actually it really is the whole SVG. So how do we use that in data visualization? Well, I made this pen to kind of show how we would use that in a map context. So we have these bloopy bits, that's also a technical term, and we can zoom in on each one, and then we're not losing the idea of that whole world. We're just zooming in on the information that we need. And because it's SVG, it's all perfectly stable for mobile and responsive, because you're just using one SVG. So you can also do something like create a flowchart. So we've got, your user is controlling all of these pieces of data, and we're just animating from one piece of the view box to another, and we're using getBbox and that svgrect that we had to, make this interactive. And that's just a giant SVG that we're kind of playing around with there. So Nikon uses a similar way of expressing this data to show us relative size of things in an interactive way. So we can uncover more information about each item. We still have some spatial awareness of its relative composition, and also we can get more information as well. Okay, showing change over time. That's probably the one that you thought I was going to start out with, but gotcha. All right. We can show motion over like how motion changes over time. If we have something like, I made this dial to kind of show different, areas that you might live in, because I go around the globe a lot and I never know what time it is or where my coworkers are or anything. So just having that little bit of visual information of showing whether it's day or night actually helps the user kind of more immediately understand where they are in time and space. And by the way, this is just a side note. A lot of times we use moment.jpg inspirational.js to gather information about daylight savings and where people are, but there's a native method called toLocaleTimeString that does the same thing. So you can actually use this and eliminate a lot of bloat and a lot of load by taking that entire library out. So in this example from Let's Free Congress, we're using a technique that a lot of you might already be aware of called scrollytelling. Scrollytelling allows us to reveal data over time as a user interacts with our page by kind of revealing elements and recombining them to tell a story. So it's a very effective means to get a point across because the user is in charge of that journey and they feel as though they're a part of it. This one you might also know from New York Times. This is another way of using scrollytelling, but a totally different way of using it because we're actually using WebGL to kind of move and manipulate this, the way that this hike went up this clip face. And what's really nice about it, again, with that spatial awareness, we can really start to get a sense of how grand that journey is as the text tells the story alongside it. So we start to see this relationship between the text and the image as it unfolds and gives us information. So there are a few ways to effectively tell a story with JavaScript, and as mentioned before, GreenSock is a pretty good one because it has a timeline in it that you can plot things, so it becomes very powerful for sequential movement. So I made this pen so that you can kind of understand how that works. So first I'm just going to show you an animation. So there's a bloopy bit in the middle, again, technical term, that fires a few times, and then there are some other pieces. Then on the GSAP timeline, there's not really a GUI for this. I'm just showing you how this all works. That is a function that's a timeline that I'm firing a few times on a master timeline. And then I have this first part that gets placed here, and then this, kind of second part that gets placed in the middle. And then this third part that fires and gets placed here. Now, if I wanted to reorder where they are on that master timeline, all I have to do is change the placement of 2 lines of code. And it fires in a different order. Or if I wanted to change how fast the whole thing is going, I can do that in 1 line of code too. So that's pretty amazing, especially if you're working and coordinating a lot of animations. I've never gotten through animating a longer thing where I haven't had to adjust the timing. So this becomes a really, really powerful thing. And GreenSock's syntax is pretty slick too. I hate live coding, so I'm going to have this monster code for you so that you can see what that's like. So I'm actually just animating text onto the screen here. So this is a simple tween. It's going to be his eyes blinking. And then if I have 2 tweens, they fire at the same time. So you can just make simple things and just have them fire immediately. Or I can plot them to a timeline. The only thing that changes is that tween max goes to TL, and then they follow each other in order. And then I can wrap that in a function and return the timeline and plot it to a master. This is functionally equivalent. And then I can add another function. These are kind of nice because then you're keeping everything organized. It's not in global scope. And you can kind of nest and reorder things. So he's going to flap now. And he's going to say goodbye to you. Goodbye. OK. So aside from being able to plot action along GreenSock's timeline, once you have a timeline, you can manipulate those values as well. So this is extremely useful for data visualization, especially if you're going to coordinate things with user events or scroll events. So we have things like tl.pause, pauses the timeline, resume, resumes the timeline, restart, restarts the timeline. You can play from X amount of seconds from the beginning or the end. Seek is a kind of sleeper hit. That allows you to kind of find one place in the timeline that it starts from. Ooh, why? Oh, should I move away from the speaker? OK, thank you. And that's great because if you have a longer animation, sometimes you don't want to watch the whole thing that happened in the beginning, especially because our lizard brains can't really remember what we're changing at the end of it anymore once it gets a little too long. We also have tl.reverse. That's really great if you're coordinating an entrance and an exit. If it's the same motion on the way in as the way out, it's like, and then you can just reuse that reverse, and then you don't have to write all of the same things backwards. TL.timescales, the one that you just saw, that allows us to change the scale of that animation, so speed it up or slow it down in one line of code. And that TL.progress is especially great for interaction because we can plot that progress alongside events. So with all of those controls, I made this YouTube-like GSAP player that you can attach a timeline to if you already have a timeline. So you can use this utility I made, and it has some options that you can pass in, or you can just check out how I made it. You can see you can slow it down, speed it up, what have you. But you can make things like this. Like that user playback control is really, really easy and simple to implement. And you may find that you want to create one of those kind of scrolly telling things. So here are some basic options. I'm putting them in two different categories because that's basically how these things, technically work. So one of them is pixel to pixel. And what I mean by that is you have a bunch of animations that are firing over time, but you're plotting them literally to every pixel on the scroll. So the nice thing about that is you always have it begin where it needs to and end where it needs to. So as you scrub that, it's always literally going to go up and down. But the problem with that is that if the user stops scrolling in some intermediary state, you can get these kind of weird like gaps where something's half there or something's coming out. So that's kind of up to you whether you like that kind of thing or don't. Another one is point triggered. In other words, you're basically going to plot on the scroll, this hook that you're going to add a bunch of events to. So you can plot a timeline to it or have something be triggered, have something like appear out of nowhere. So there's a bunch of different libraries that are capable of doing each one, and some of them are in both categories. So scroller is really great for pixel to pixel movement. You can map the timeline progress that we just saw, that progress we just talked about, to a scroll event. That's semi-manual. You can use scroll magic, which wants to be used with either GreenSock or Velocity.js. Or you can use Scroll Story, which was made by the New York Times, that shows a lot of the stuff that we were just looking at. They coordinate a lot of things with that. It uses jQuery as a dependency, just a heads up. And the point triggered, there's waypoints, which I'm a big fan of. That basically just it's really small. It just adds like a little hook that you can attach things to. And you can trigger single timelines off of an event, like a scroll event, from a certain distance from the page. I do that, or I use waypoints a lot. Scroll magic, again, will fit in both categories. Scroll story fits in both categories. And there's another one called graph scroll that's pretty nice, that'll allow you to lock things into fixed positions as you're scrolling so that you can tell a story and the data's not moving around, or at least the container is not moving around as you're telling the story. So why do we care about telling a story? Why am I focused so hard on that? What benefit does that have to us? Well, we as humans crave story. If you think about it, that's really how you relax, probably. A lot of times we get out of work and we want to go to a bar with friends, so we're telling each other stories, or you go home and watch Netflix so you can have a story told to you, or you pick up a book so you can read a story. It's because we get dopamine rushes from hearing stories, and the reason for that is so that we can imagine situations that might be potentially dangerous to us at no cost to us. So we can mentally prepare for situations we might not have thought of. So our body kind of rewards us for those sensations. So now think of the first time that you ever cried when you saw a story. The chances are it was probably animated. Motion is really, really powerful to tell these kind of stories and allow us to make stories of our data. It's really powerful to engage our imaginations. And the other thing that emotion does is it attaches to our limbic system. What the limbic system does is it allows us to recall information more clearly. So if you make somebody feel something while they're looking at your data, they're actually more likely to remember it. So we can play with this. We can have our users interact with what we build. In this case, I made a little Wall-E guy that's being coordinated with the JavaScript framework Vue, as we mentioned before. I attached the mouse move event to track the position across eClient X, and I'm plotting it and coordinating it with one of those timelines. So I built out the timeline of him reaching his arms across, and then I'm plotting those coordinates along while he's playing with that. So we can marry user scroll with the layout of our data and use different forms of storytelling as well, like video, text, pixel by pixel mapping of how things are occurring. So we can have all of these things play together really well. You can see how we have that data that was locked that I was explaining before, and then we're kind of zooming in on the lake and how it changes over time. So we can coordinate narration in SVG and HTML elements all in one place. So, funny story, I made this pen, and Sarah Swedan, who's another web developer, was going to a conference, and she asked if she could show my pen, and she said, she showed the pen, and then she said, how many introverts are there in the audience? And nobody raised their hand. Sometimes it's useful to animate the words to complement the image. I use a plugin called Split Text that's really helpful for this because it breaks things into character, words, or lines, but honors natural line breaks. So the first block here instantiates the split text, and the second is how you would use it in one of those timeline calls that we mentioned before. So we can make something like this. Oh, we don't have sound again? Does it shut off? So you don't have to be so literal about it like I was. Also, it looks better on the web. It's kind of janky when you try to make a screen grab of it. So I would definitely check these things out on the web. Shirley Wu, our MC today, made this amazing scrollytelling site that allows you to interact with every line in Hamilton. And you can see how each piece of the story unfolds and guides you through every part of that data. So the last and final part that we're going to talk about today is revealing for clarity, because that's actually important. So revealing for clarity is one of my favorites because it actually makes the animation a piece of the data. So what do I mean by that? When we use motion, the dimension of time can be a piece of information in and of itself, and a really powerful one at that. So Mike Bostock has this example of the Walmarts across the nation. You can see how many stores they are and where they're collected, but it's a very static example. So I took this piece and altered it, and I animated each of the hexes according to when they were opening across the country. So now we're not just showing where all of the Walmarts are, we're showing where they arrived and when. So time is another dimension of that data and actually gives us more information about how everything came to be. And a lot of data is affected by time. So in this wind map example, we're not only expressing the lines of where the wind is going from or coming to, but how the wind will be moving over all of these areas. So slowly revealing this information mimics the form that we're representing also. And Nadi Bremer, who's going to speak tomorrow, did this wonderful constellations data visualization. You can see the relationship of ancestry as their stars down the page, which is really lyrical and beautiful. But when you hover, everything else fades away, and then you can start to see the relationships of each piece and where they map to in that greater space. So you can't actually see those relationships as clearly until you start to reveal them in a different way. So just as we did in the last few examples, it's nice to get data on the page and then alter it with animation. So if it sounds like it's a lot of work to coordinate all these things at once, don't. Actually think about it the same way that you have been, getting a static piece of data on the screen, and then you can slowly unveil things, or you can reveal other parts. So that's partially so that you don't have to feel like you're juggling too much at once. It's much easier to think of one at a time. So I grew up here in San Francisco, and a lot of the families that I once knew have suffered under the Ellis Act, and they were forced out of their homes during the housing boom. So basically all of these pieces here, this visualization is showing the Ellis Act evictions in doing a really great job by showing some of that secondary action too. It's not just showing those pieces, it's showing those big red booms as they kind of show how these people were affected. And they also have this timeline as it adjusts and it goes forward that you can play around with, because sometimes it takes a really long time to see all of these things occurring. So the user can actually scrub through the timeline and see the differences. So I do think that pairing these kind of timelines or this visual information with some sort of interaction that the user feels like they're in control of can be really powerful. And this kind of interactive storytelling doesn't need to be so one-to-one either. There are ways of teaching story through data, metaphor, and animation that complement a more playful data set. So if you consider the look and feel of this animation versus the last one, the tone should kind of complement the interpretation of the data that you're looking for. This wouldn't really work with a really highly politically charged animation, but this is for kids to get them interested in how things occurred over time. So it's really, really playful, and it works very well. So we can even combine all of the techniques that we talked about today into one experience for a really welcoming, immersive story. I really like this one from Pudding.cool that talks about NBA draft picks. So we have all sorts of things that we just talked about in here. So we've got things like revealing, filtering, greater context, scrollytelling, playing with text and image, and all of that helps us bring the data together to tell a cohesive story. Animation can be extremely meaningful. Motion gives us another view onto our data. So as you move forward making these data visualizations today, in the next couple of days, consider leveraging these techniques to capture your user's attention and bring your data to life. Thank you so much.
You get your start with scrollytelling? Like how do you break into that, especially if you want to present analytics?
Oh yeah, I think actually it's really challenging with like very, very dry data sets, especially like analytics. But I think probably the easiest one of all of them to kind of get going with is like the waypoints and adding a timeline to it, because you can have finite control over how that timeline works, and you're not. Sometimes with the pixel-to-pixel ones, you may be worried about scroll jacking, or if they're scrolling too fast, some things happen. The nice thing about triggering off of one point is that it just fires, and then the whole, the JavaScript takes over. So that one, I think, is probably the best for like if you haven't done it before. The waypoints is a really, really great one to start off with. Scroller is also really beginner friendly. You're basically saying you're just attaching HTML attributes that change to attributes over time. So that one's a really cool one to start off with too. But yeah, that's one that like you have to pay attention to the way that the scroll moves. So yeah, great question. Yeah.
How does GreenSock play with D3?
Oh, pretty well, actually, because they have similar ways of grabbing things out of the DOM. Yeah, I would say the only gotcha that I've found is that you have to, if you're loading a big data set, especially from afar, make sure that you do some sort of set timeout, because GreenSock will look for it in the DOM, like perhaps before D3 has it in there. So that's the only, promises can help with that, and there's a lot of ways to deal with kind of async data to make sure that it's actually on the page. That's the only thing I would say, but yeah, they play really well together.
What part of the SVG spec do you feel that the data visualization community is not taking advantage of?
Oh, that's a good question. I would say filters, probably. I really think that SVG filters, like there's a bunch of pens that I have that like make ripples in a pool and like, do all sorts of crazy effects because we have things like distortion and stuff. The challenge with filters is they can be CPU intensive. So if you do animate a filter, what I do is I have a helper function that removes the filter. The filter isn't on there at all. It applies the attribute and then removes it immediately when I'm done, so that it doesn't incur any extra performance costs. But yeah, there's just so many cool, filters and like great ways to manipulate data with them. So, yeah.
We have a SPG filter session after lunch. So we're gonna figure it out together. That's a good time to do it.
Is that it? Oh, one more in the back.
I feel like so much of what made those animations effective was the timing themselves, and just curious how we can learn more about motion design or picking something that makes it as effective as you saw.
Yeah, actually, without it sounding like a commercial, that's like the first block of time that I spend doing those web animation workshops. We dig into theory, and we spend about 3 hours just on theory about timing and spacing and secondary action. A lot of this stuff we've learned from animators of the past. So the history of animation is way longer than the history of the web. So we're kind of standing on the shoulders of geniuses. No need to reinvent the wheel there. There are some things about timing and spacing on the web and tooling, especially because different motion libraries lend themselves to different kinds of eases. So that's something we talk about and play around with as well. Yeah. Yeah.
So going back to your original Neil Halloran example, he has millions of views on YouTube. And so how do you think about using all these tools as an engine for creating data-driven film versus interactives? Because he has both, and my guess is the majority of people have seen his work through the film because it's just so easier and just so much more consumable.
Yeah, I'm not so good at making things that aren't for the web, so I might be the wrong person to answer that question. I tend to just think about it how we would pull it off in a web page. I know other people are really good at After Effects and stuff. That seems more complicated than JavaScript to me. I know it's supposed to be easier, but it seems like it's not. But that said, I agree with you. I think that there's a lot of exposure that you get when you can tell a story and narrate it in that way that maybe the web is missing out on, or would be so CPU intensive to try to do so many of those things at once. So it's a great thing to bring up, and yeah, it's definitely worth considering.
A lot of what you showed, including scrolly telling, is pretty linear, and the history of animation has always, up until the web, been about linear animation. How do you apply storyboarding techniques from linear animation to nonlinear interactive?
Yeah, I actually try to break things down into, one thing first I'll talk about storyboarding really, really briefly. People get scared of storyboards because who wants to make a giant comic before they start animating on the web? But I do really, really sketchy kind of, things that I can get down in a couple of seconds. I think that actually helps to plan out things like interaction, because if you're not plotting everything out like a comic and you're just thinking about things in, many different spaces, you can plot out different things much more quickly and much more sketchy. So that said, I'll still create a linear timeline and then have people interact with it. So even if I'm making something on a drag or doing something else, I might make an entire timeline and then have the motion that's interacted with it be kind of, change up. But in terms of filtering and reordering, like some of those examples there, when I've done those kind of things, it's mostly for me drawing it first and having this idea of it, but then the data kind of informs how it actually ends up being. It usually doesn't end up the same way as I started from, because things kind of like shift and change, and I discover things that kind of make it look better, or like timing that made it look better as I'm working with it.